a future value annuity. Okay, so here's our formula. The future value, and sometimes they'll refer to this with like A, it means the amount, but the FV stands for future value is equal to the regular payments, which is our R here, multiplied by 1 plus, this is like the compound interest rate, but you have to calculate it to the power of n minus 1 all divided by I. And really what it is n is also years times compound period. So R is that interest rate they're going to give you in the question. YR is the number of years, assuming it's like the interest rate is measured per year, and almost every question you'll ever get is done like that. I've never really seen it another way. Banks always set it up that way. That's just how humans kind of set those things up. It's always on a yearly setup. And C is the compounding period, which is really important. So we'll read through this question, make sure we can like pull out important stuff. Determine the accumulated value of $650 deposited at the end of every 3 months for 4 years at 10%. That means a year. Compounded quarterly. That's a ton of like. This whole thing is pretty much important. They were depositing $650 at the end of every 3 months. Okay, so we're gonna have to figure that out. And it's for 4 years, so that kind of gives us our time. The interest rate is 10% a year, and it's being compounded quarterly, and we can kind of figure that out from above, but we'll talk about it. So, in order to make annuities make sense, the regular payments, that's what it's a 650, it's going to be our regular payments, need to be the same as our compounding period. Otherwise, it gets really complicated. All of your questions, I'm sure, will be set up that way. But just kind of keep that in mind, because if you ever in the real world get something where it's not quite like that, it does make the question a little harder. Okay, so let's define what we have. Our regular payments, they're paying $650 every time. So R is 650. Okay. We clearly are looking for FV. We don't know what it is. The interest rate is going to be 10% a year, so that's going to be the R. And 10% we need to turn into a decimal, which is 0.1. Okay. Compounded quarterly. So compounded quarterly means it's happening 4 times a year. Oops. And you can kind of figure that out from this part of the question. So compounded is 4 times a year. And the way you can kind of figure that out is every year there's 12 months, right? So think of it like if they're happening every 3 months, so it would be like 12 divided by 3 will give us that idea of 4. So every 3 months we make a payment out of the 12 months in the year, and it gives you that idea of 4. So both of these told you the compounding period. Is that giving us everything? R, yep. And then we got to calculate. Oh, did it tell us how many years? Oh, it did, yes. I just didn't write it in. Our years are 4 years, so YR is equal to also the number 4. So we need to still calculate what I is going to be. We'll do that over here. I is the interest rate, 0.1, divided by compound period, which is 4. And our N value is the number of years times the compound period, which is also 4. So that's going to be 16. And this one's going to be, I don't know, it might be a nasty number. Let's see. 0.1 divided 4. Oh, that's not bad. 0.025. So we can kind of write that one out. 0.025. Okay, so we've got all of our values. Now it's just kind of like plugging into a formula and solving. So the future value is equal to the regular payments. So that was our 650 times 1 plus our I value, which is 0.025. All to the power of our N, and our N value we decided was the power of 16. Subtract 1, okay, and then all of that is divided by, value of I again, and I is again 0.025. Now for future value, it's really nice. We just got to solve everything on the right side of the equation. You can probably do this all in one step in your calculator, so we'll kind of try to do it together. Might be difficult. I'll simplify this one really quickly. So it's going to be 650 times 1.025 to the power of 16 minus 1 divide 0.025. Okay, let's pull out our calculator here. So the best way to think about this is start at the innermost bracket. We start with this bracket here, put it to the power, then we subtract 1, then we multiply by 650, and then we divide by this number at the end. So that's going to be like our game plan here. So 1.025 to the power of 16 gives us that. Great, so we have that value. I'm going to take that number and I'm going to subtract it by 1. It's our new number. Now that I've done everything in the bracket, I'm going to multiply that old number here times 650. Okay, and then while that we've done that, we divide by this value here. Take that number and divide it by 0.25, and our future value should be $12,597.14. So future value is 12,000. I never memorize this. I always get the first two. 597.14. 597.14. Great. So we've figured out how much you have in the future. But I'm going to extend this question further. What if they ask us how much do we make? Okay. The compounding periods. No, that's the wrong button. The compounding periods, 16. They tell us how many payments we actually make. Okay. So since they've told us how many payments we actually make, we're going to use that information to figure out how much money we actually put into the account. Okay. So we actually take this 650 and multiply it by the number of payments we made. So we'll do that below here. We had 16 total payments at $650. Okay, so we multiply these. And this 650 and multiply by the 16 payments we made. And we paid $10,400. So because this earns interest, we can figure out how much interest, how much money we've actually earned, okay? So we take the value, 12,597.14, and we're going to subtract by the true amount of money we put in, okay? And that'll give us 14,791 and 2. So we've earned in 4 years $2,197.14 through this annuity, okay?